planes, angle between two planes. Two planes in 3D. So remember from your previous knowledge from dot product, in the section when we were doing the dot product of two vectors, suppose that this is our vector A and that is our vector B, and theta is the angle between them. Theta, it is the angle between them, and we have this formula for finding, we can use this formula to find the angle between these two vectors, which is cosine theta equals A dot B divided by the magnitude of A, magnitude of B. By using this formula, we can find the angle between the two vectors. So now, what is the main point here? The angle between the two planes. The angle between the two planes. So suppose that this is our plane. This is our plane. Let's say P1, and we have another plane. You can imagine like this. Okay, so suppose that this is the plane P2. We want to find the angle between these two planes. We want to find the angle between these two planes. So how can we find this angle? But the main thing you have to note down is the following, which we are going to use is the following, that the angle between two planes, this is actually equal to the angle between their normal vectors, angle between their normal vectors. So this is the fact we are going to use to find the angle between the two planes. Okay, so suppose that this is the plane P2 and it has a normal vector, let's say n2, and here we have the plane P1 and the P1 has the normal vector, let's say n1. So the angle between these two normal vectors, it will be the same between the angle between the two planes. So let's solve this thing with the help of the following example. So in this example number 7, we are given two planes and we need to find the angle between them. So our first plane, it is given by x plus y plus z equals to 1, and the second plane, it is x minus 2y plus 3z equals to 1. Again, you want to recall the previous knowledge from the last lecture. We know that the equation of a plane, it is given by this: ax plus by plus cz equals to d, and the numbers which are written with x, y, and z, these are the components of the normal vector to this plane. So the normal vector to this plane will be, we can obtain by just writing these values of a, b, and c. So this is the normal vector corresponding to this plane. So corresponding to plane P1, we are going to have this n1, which is our normal vector. It will be given by 1, 1, 1, and the normal vector corresponding to the plane P2, it will be given by 1, minus 2, and 3. So these are the normal vectors between them. The next thing you need to do is to find the dot product between these two vectors. And remember from your previous knowledge, how do we find the dot product? We multiply the first component of the vector n1 with the first component of the vector n2, that is 1 multiplied with 1 plus 1 multiplied with minus 2 plus 1 multiplied with 3, and that will give you 1 minus 2 plus 3, it is equal to 2. The next thing you need to do is to find the magnitude of the vector n1. It will be equal to 1 square plus 1 square plus 1 square, and when you simplify this thing, the answer will be square root of 3. And the magnitude of the vector n2, it is given by, we take the square of each of its component, 1 square plus minus 2 squared plus 3 squared, and when you simplify this thing, we get 1 plus 4 plus 9, which is equal to square root of 14. Now substituting everything in the formula, so cosine of theta, let us suppose that the theta is the angle between these two normal vectors. It is given by n dot, the dot product of these two vectors divided by the magnitude of n1 multiplied with magnitude of n2. Substituting everything here in this formula, we get this square root of 3 multiplied with square root of 14, and that will give you theta theta equals cosine inverse 2 by square root of 42. So by using this formula, we can find the angle between the two planes. So the main thing you need to understand that angle between two planes, it is the same as the angle between the two normal vectors. In the next part of this question, he is asking us to find the symmetric equation for the line of the intersection. Okay, so we have this find the symmetric equation for the line of the intersection of the two planes. So how we are going to find this thing? So remember one thing, that two planes, the intersection of two planes is a. So this is the part B of the question, which says that the intersection of two planes, the intersection of two planes is a straight line. The intersection of two planes is a straight line. And again, you remember from your previous lecture, in order to find the equation of a line in 3D, we need two informations. We need 2 points, two information, that is, we need a point, and the second thing we need is the direction vector, or the vector along which the line is parallel. And then we can find, by using these two information, we can find the equation of equation of the line. So remember this thing. So suppose that this is the plane P1, and this is the plane P1, and you can imagine like this. This is the plane P2. This is the plane P2, and the intersection of these two planes, is a line. You can imagine like this. So this is our line, and we need to find the equation of this line. So how can we do this thing? So in order to find the equation of a line, first of all, we need a point. Okay, we need a point on the line, and also we need the direction vector. So the first thing we have to do is the following, that is, we are going to find, we need a point on the line. Okay, we need a point on this line. So how can we do this thing? In order to find the point of intersection, what you can do, this is a simple procedure. You need to remember that, put z equals to 0 in P1 and P2, that is the plane 1 and the plane P2. So the plane P1, it will give you x plus y equals to 1, and the second plane, it will give you x minus 2y equals to 1. And if we solve these two equations simultaneously, since x has the same coefficients, so we can subtract these two equations. So on this side, this x will cancel. Okay, and here we get 3y equals to 0, which implies y equals to 0. And substituting this y equal to 0, let's say here in this equation, so then we get x equals to 1. So this is the point P. This is a point. Let us denote this thing with x0, y0, and z0, and it is given, it has the coordinates 1, 0, and 0. But the next thing we need to find is the direction vector. How can we find this direction vector? We already have the normal vector to the plane P1 and normal vector N2 to the plane P2. We will find the cross product of these two vectors, and that will give us the perpendicular vector to the line. Or you can say it will be a vector which will be parallel to the line. So this is how we are going to do this thing. So we can write this thing in the following way: to find the direction vector for the line. What we need to do, we will find the cross product of these two vectors n1 and n2. In the first row, we will write I, j, k, and in the second row, we will write the components of the vector n1. In the second row, we will write the components of the vector n2, 1 minus 2, 3, and then we will expand this thing. That will give you 3 plus 2, and remember here you have to write plus, minus, plus, and then minus j, 3 minus 1, plus k, minus 2 minus 1. When you simplify this thing, it will give you 5i minus 2j minus 3k. So these are the direction vector of the line. These are the direction vectors of the line. And remember one thing, that will give you So by using these two things, we will find we can find the symmetric equation of the line, which is given by this: x minus x0 our a, y minus y0 our b, and this is equal to z minus z0 our c. So the values of x0, y0, z0, these are 1 0 0. And what are ABC? ABC are the components of this cross product n1 cross n2. So a equals to 5, b equals to -2, and c equals to -3. So we substitute these values in this equation. We get x minus 1 over 5, y0 is 0, so we get y over -2, and z divided by -3. So this is the symmetric equation of the line. So this is the symmetric equation of the line.